there, welcome back to Spring into Math 7. I'm Mrs. Campbell, and today we're going to be talking about making connections between 2 and 3 dimensions. Let's review quickly what we've covered so far. Remember, a cross-section is the shape that you see when you make a slice through a solid. A solid can have many different cross-sections depending on where you make the slice. We talked about this in our last lesson. So let's consider a hexagonal pyramid. Cross-sections perpendicular to the base will be triangles, but cross-sections parallel to the base will be hexagons. Okay, it's also possible to take cross-sections using planes that are neither parallel nor perpendicular to the base. So, for example, look at this hexagonal pyramid. It has been sliced at a slant. It's actually going this way. Okay, so the cross-section is what? It's a pentagon. It's got 5 sides. So this is just to show you that cross-sections are one way that 2-dimensional objects are connected to 3-dimensional objects. A second connection that we can make between 2 and 3 dimensions comes from the fact, and I'm going to highlight this, you might want to write this down, that 3-dimensional solids can be created by rotating 2-dimensional objects around in a line. Okay, so for example, rotating this half circle below here, if we rotated it all the way around on the line, it's going to create a sphere. So let's try one. Here's an example. Identify the solid that is created when the following shape is rotated around the line. Okay, here's our shape. So just imagine if you rotated it around the line. Did you figure out what it would be? It would actually be a cone, and it would have a radius of 5 centimeters. Okay? All right, continuing on, kind of on the same problem. Example B is asking us to find the volume of the solid from example A, the one we just did. So the volume of a cone is pi r squared times height divided by 3. We know that the radius is 5 centimeters. Now, to find the height, we're going to have to use the Pythagorean theorem, which is a squared plus b squared equals c squared. Plug in what we know. 5 squared plus h squared equals 9 squared. And ultimately, that leads us to a height of the square root of 56, which is just about 7.48 centimeters. So now we can use that for height. Now, the volume of the cone is, plug everything in, pi times 5 squared times 7.48 divided by 3. When we work all that out, we get a grand total of a volume of 195.83 centimeters squared. In example C, same kind of thing. It says identify at least 3 2-dimensional shapes created by cross-sections of the solid from example A. Okay, let's take a look at the little note here in blue. It says cross-sections, here's our solution. Cross-sections can be taken parallel to the base. They can be taken perpendicular to the base, and they're going to be triangles. And when the cross-section is taken at a slant, there's many other possibilities. 2 additional cross-sections that we could see is an ellipse or a parabola. All right, everyone, that just about does it for this lesson. Thanks so much for joining us, and we'll see you next time. Bye-bye.